The running variable or score variable is the entrance exam score to enter in the Boston Latin School. Here is the fraction of the students enrolled at the Boston Latin School. If the score is below the cutoff, the applicant, he or she is not allowed to study in the Boston Latin School. But not everybody who get a score higher than the threshold, they are going to study at the Boston Latin School. Some might just move to another school in another city or another country. And this is the case of fuzzy regression discontinuity. You don't have full compliance. If everybody that score above the threshold, if they go and study in the Boston Latin School, in this case you'd see all these data points as a straight line in the one. In this case it would be a sharp regression discontinuity. We still have here the entrance exam score relative to the Boston Latin School cutoff. But the Y now is the peer's average 4th grade math score. This jump, it's almost one standard deviation. The students who are above the threshold, they study with peers that is almost one standard deviation compared to not pass in the Boston entrance exam. The research question here is how the peers or classmates affects the math score. This X bar is the average 4th grade math score of the I7 grades classmates. And the Y is the student I7 grade math score. This parent's I indicates that it is the classmate's score, not the individual Y. And we control for the student I 4th grade math score. We are interested in θ1, that is the peer effect, and θ1 hat by ordinary square is 0.25. The ordinary square regression is telling you that if you study with peers above one standard deviation math score, your own score will increase in 1/4 of standard deviation. Let's now see the fuzzy regression discontinuity. We still have the same X bar, the average 4th grade math score of the 7th grade classmates. This phi is exactly what you saw in the chart before, this jump here. As I said before, it is almost one standard deviation. D equal 1 if you are above the threshold, the cutoff, and 0 otherwise. Therefore, we are using D as IV instrumental variable. D is determined by the running variable, entrance score. D is a great IV because it's uncorrelated with the error term, as D is determined by the running variable. Okay, this is the first stage of the instrumental variable estimation. We run ordinary square in this regression here, and we get the X bar hat, the predict value. And then we plug the X bar hat in this second stage. We get the lambda hat 3 steps least square minus 0.023 and the standard error 0.132. This is pretty much 0 and not statistically significant. See that the fuzzy regression discontinuity indicates that the peer effect does matter, at least for math score. See this chart here. The Y is the math score in the middle school. There is no discontinuity around the cutoff. If you run a sharp regression discontinuity here, the whole is virtually 0 and not statistically significant, confirming that there is no discontinuity here. That's why here the fuzzy regression discontinuity, the effect of peers, classmates, is 0. This θ hat from ordinary square is likely to be biased. This X bar is likely to be correlated with the error term.
But my boy Forrest is going to get the same opportunities as everyone else.
Is that Mr. Gump? Mrs. Gump?
He's on vacation.
Some mothers, they do whatever they can to send their kids to a better school. But does it matter? The Y here is the fraction enrolled at any Boston exam school. The students who didn't make to the Boston Latin School, they end up to study in similar prestigious schools that demands entrance exam. If you pick up at random somebody from the street and throw away at MIT, does this person will be in the end of the process smarter